Welcome everyone, and thanks for joining us today. My name's Jocelyn, and I'm the marketing coordinator here at DoubleRadius. As always, the goal of our webinar is to showcase technology that will help you build better networks. Today, we're excited to host Ericsson for a special presentation on their 5G multi-link platform. Joining us from Ericsson are Arthi Gunasilan and Andre de Villiers. Arthi is the Director of Strategic Partnership and Channel Sales. Andre has been with Ericsson for 20 years, during which time he's worked with microwave and routing productions covering every generation of wireless since 2G. Before we get started, a couple quick housekeeping items. First, enter any questions you have into the customer questions box. The sooner the better, as we'll answer them in the order they come in during our Q&A session. Second, after the webinar, a survey will pop up on your screen. Please take a minute to complete it, as we'd really appreciate your feedback. And with that, I'll hand it over now to Arthi to get us started.
Thank you, Jocelyn. Good afternoon to all of DoubleRadius webinar attendees. I hope everyone is having a good day, staying safe, and gearing up for the holidays. As Jocelyn mentioned, my name is Arthi Gunasilan. I am the Director of Channels and Partnerships, focused primarily on the transport solutions, which consist of routers and microwave, and also our fixed wireless access solutions. We are really very happy to be doing this today for you all with DoubleRadius via Wincom Technologies. And hopefully once this pandemic is over, I will get the opportunity to actually personally meet with all of you all someday. Now, before we get into the meat of the presentation, I would like to gauge where everyone is in the 5G transport space. So we've got a poll question, and each one of you will have about 15 seconds to answer this. And yeah, let's keep this interactive. Okay, so for all those who don't know about Ericsson, we are a global company based off in Stockholm, Sweden. Our North American headquarters, though, is in Plano, Texas. That's where both Andre and I work off. And we have about 95,000 global employees and 9,500 local employees here in North America. Our portfolio is divided between 4 different major areas. We've got our networks portfolio, which is where our radio, like point to multi-point, transport, which is our microwave, and routers fall under. And then we've got digital services, which is where our management system, billing systems, and our core products fall under. And then we also have a unit that caters towards our operators for managed services, where we help our operators manage some of their network operations. And then last but not least, we've got a business unit that caters to emerging technology. So this is where our IoT and our enterprise related solutions would fall under. Now, next slide. So this is an example of all the different customer base that we cater to. As you can see, our major customers are a lot of our tier 1 operators. We also cater to the cable customers, and also to tier 2, tier 3, including WISP customers. And we've also added enterprise customers such as in the utility, oil and gas, hyperscalers. Those are some of our new customers that we keep recruiting as we get into the 5G and IoT space. Now, next slide, Andre. Well, we are proud to say that as of, as of right now, at least, in North America, Ericsson is the #1 vendor leading all 5G deployments. Globally, we have 72 live networks with our 5G equipment, and we have announced about 118 5G contracts in about 37 countries worldwide. And with this, it would actually give me a good segue to Andre, who is our subject matter expert for 5G transport solutions, which consist of both router and microwave. Andre, I would like to hand it over to you.
Thank you, Arthi. It's a pleasure to be here, and I hope that we can have a nice interactive discussion. Arthi has kind of set the stage very well with, kind of the introduction to Ericsson and 5G. I don't intend to talk about 5G radio access very much, other than to kind of set the stage for the point of today's webinar, which is around transport networks. But I do want to say that 5G, just like every other GE or generation before it, has always kind of raised the bar when it comes to what it requires of the transport network. With 5G, we're talking about more bandwidth. So when you're talking about some of the new spectrum and the way the channels are laid out with 5G, we're talking about driving gigabit and well beyond kind of capacities to the end user potentially. So and of course, as you wrap that up into what's required in the backhaul and maybe even in some of the other interfaces on the transport network, you can imagine that bandwidth is, of course, going to be driven upward with 5G. But also going up are connections, the number of connections. So we haven't really seen this yet because most of 5G deployments have been as kind of the next generation for what we call mobile broadband, which is everybody walking around with their phone and looking at video and whatever else you do with your phone. That's kind of the mobile broadband use case, as we say. But really, the power of 5G comes in what we're going to do with new use cases, and that involves a lot of Internet of Things applications, whether it's just millions and billions of sensors out in kind of commercial networks that are operating equipment, that can be controlled with 5G, or whether it's critical IoT, which would be something like healthcare. Kind of the classic use case we talk about is something like remote surgery potentially, where the latency that would be required for such a use case would be very strict, obviously. So, but we're not talking about that here. We're talking about just the sheer number of connections, and there we're that obviously is going to be increased as we continue to deploy 5G and those use cases kind of get unlocked. Also kind of increasing is the amount of security required, because you're opening up all of these new points into your network. You can't necessarily trust that that every one of those points is physically secure or even logically secure. So you have to implement higher levels of security within your network. But so that's a number of things that are kind of increasing with 5G, but we also have some other requirements like latency, as I mentioned, being lower and lower. And this is not just for the critical IoT, but also with some of the different architectures, which is kind of the next point I'll bring up. In basically every other generation up till now, we've had what we would call a distributed access network, distributed radio access network, or distributed RAN, where your radio equipment and baseband equipment are sitting at some site, and it's connected to your core network via a backhaul link. Well, as we moved into kind of more evolved 4G and now into 5G, some of that gets to be split apart for different reasons. And so we have, it started basically with front haul. Some of you may have, been familiar with front haul, which is basically that connection between the radio and the radio baseband that is implemented over something called CBRS. And that connection, as you start to break that apart for performance reasons on the RF environment, then you start to come up with operational efficiencies by centralizing the baseband, and now you're carrying CBRS over a distance. So then that becomes something an architecture we call CRAN, or centralized RAN. Then other functionality has broken apart as we kind of continue to study the most efficient ways to deliver this. But then we have all the other architectures called vRAN, for virtual RAN and to take advantage of kind of some of the hyperscale technologies. And then also ERAN or elastic RAN that allows for tighter coordination between radio assets across multiple areas basically. So those things, when you create those new interfaces, you create very different requirements for the different sorts of traffic that traverses that. So when we deliver 5G transport, we have to take into account all of those interface requirements, and so a lot of that has been taken into account with the Ericsson portfolio. As we go, we'll have even higher, even kind of more sophisticated concepts like network slicing, which is how do you take pieces of every asset along the way in the 5G network and kind of dedicate it to a certain end customer or a certain industry or something like that. Then transport automation, which tries to abstract the complexities inside the network, to something at a higher level that you can kind of deal with on a service level. So this becomes a lot more sophisticated than your traditional backhaul. And then of course, synchronization becomes even more important because of some of the nature of some of the radio equipment isn't just FDD. There's some TDD technologies that are being used, which kind of implicitly requires tighter sync, and then the ability of the transport network to kind of pass that sync through is important. And then of course, with every generation, we have to keep our total cost of ownership within reason. We can't the classic problem of having cost in your transport or cost in your network overall that are scaling with bandwidth demand, that just doesn't work. So the cost has to stay relatively flat, even though you're driving 10 times more bandwidth, let's say. So these are all the kind of the requirements that 5G is imposing on the transport network that Ericsson has been spending a lot of R&D into its products to try to address. So I'm going to talk about two parts of the Ericsson transport portfolio. One is our microwave portfolio called MiniLink, and the other on the far right of this graph is the router portfolio, the access routers called the Router 6000. So kind of focusing on MiniLink. So MiniLink is the brand name for our point-to-point microwave radios. We have basically paired point-to-point microwave deployments with the evolution of the radio networks over time, and that has allowed us to deploy over 4 million radios in the world. That has allowed us to achieve that #1 position in the market, really throughout the world, 180 countries. What I like to say about that kind of coverage is that we've been in the really cold regions like Alaska and Greenland, and really hot regions like the Middle East, and therefore the sort of climate range that we've seen is accounted for in in how we have designed the radios and in the solution overall. So we have well over 800 customers, and there's a few little tidbits of kind of capacity milestones that we have achieved along the way. A couple of them of note is the second one, 100 gigabits over 1.5 kilometers using E-band. So E-band, as you may know, is a higher frequency that gives you lots of bandwidth, and kind of the state of the art right now is about 10 gigabits per second in a commercial product. We've already gone beyond that in some prototype work with a customer out in Greece, where we've used those E-band radios in combination with MIMO technology to drive. It's actually 138 gigabits per second across a river out there. And then the kind of the other end of the spectrum is on the long haul side, where we're talking about 128 kilometers, 1.6 gigabits per second. and that is that reference is remote island in the Philippines over water, delivering over 1.5 gigabits over that distance is quite an achievement. So the portfolio covers everything in between, and that's what I'll show. So what we have, this is more or less our the current generation of the MiniLink portfolio. And that's the portion that we've kind of made available for channel partners and channel sales. Of course, we have some older products over that period of time, but we've evolved those products, and we're talking about MiniLink, and it's segmented into kind of 3 portions. We've got the all outdoor MiniLink, which would be like the MiniLink 6366 is a 1 or 2 carrier radio that would be synonymous with some of like your dual core systems that you might see in the market. We have the 6351, which is a unlicensed V-band product for carrying up to 1 gigabit per second, and the 6352, which is an E-band product, which delivers 10 gigabits per second, potentially 20 if you double up the capacity with XPIC. So those are kind of standalone all outdoor solutions. We also have a split mount solution, which basically contains your baseband down at the base of a tower, let's say, and the radios that you see on the bottom really up at the top of the tower that are paired with your antennas. This allows you to build your networks very modularly and flexibly, and keep your costs way down when building networks with split mount technology, as opposed to repeating that baseband functionality on both ends of every link, even though some sites might be facing multiple links. You can save like up to 40% of your capex by using a split mount kind of an architecture. We support both, but like we like to say that it's a set of Legos that you can build your network with however you need to. And then I won't speak as much about the long haul technology, but the long haul technology on the right is your classic all indoor microwave radios that reuses some of the chassis that you see in the middle. So we kind of get some economies there, but the kind of the magic of the long haul portfolio is the advanced filtering that allows some very good RF performance over long distances. Talking about the all outdoor radios, here you kind of see the lineup of them. I'll kind of highlight on the 6366 because it's similar to a lot of the products that we see in the space that you guys are in. This is a product that has some mounting flexibility in that you can mount the baseband box, which is the 6366 itself, kind of behind the radio, or you can mount it on a rail separate from the radio, or you can even mount it to a pole separate from the radio. This allows us to be more modular with it, and we don't introduce a single point of failure into a link. You'll see that this 6363 radio is actually still part of the 6366 solution, and therefore you've got some building blocks there that allow you to not have a single point of failure in a link. So you can have 2 of those radios, lose one, and still be able to maintain a connection to across the link. 6352, moving over to the right, is an E-band product. We're talking about 80 gigahertz lightly licensed links that are very good for like a fiber extension sort of a use case. Similarly, 6351 is like that as well. Maybe a little bit shorter links, maybe something you would use to distribute connectivity within a campus environment, or amongst street lamps or light poles along kind of a street grid, you could say. And then the last product on the right I'll point out is the 6365. This is actually 2 radios in one, so that we can continue to deliver more and more capacity. we have the 6365, which has 2-channel radio kind of built into that same form factor. And there's different reasons for wanting to pack that all together, which we can get into in a more detailed webinar later. Kind of complementing the radios, the 6363 and the 6365 are these chassis that go with the split mount system. So I won't get into each one of them. The kind of the point of this slide is to say that we have a number of chassis to meet all cost points. So if you need a very simple split mount system, at least cost as possible, you'd probably use one of these 6651s on each endpoint, and you'd achieve a very good cost performance on that link. As you build in terms of the number of links coming into a particular site, you would kind of go up this scale onto the 54 and the 55, or even into the 90 series, which give you more and more kind of directions and radios that you can support. It also, with the 94 and the 92, gives you some protection of the baseband. So as your sites get more complicated from a number of channels or an amount of protection standpoint, you can pick the chassis that best suits you there. Of course, we have a full suite of antennas that are both integrated and separate, kind of the left and the right of this picture. Obviously we like the integrated antennas because it gives you better RF performance. But there are some applications where you need the very large antennas to go really long ranges. We also have a line of dual band antennas which support a solution we call the multiband booster, where we might take 2 disparate frequencies, like in the US, like 18 gigahertz and 80 gigahertz, or 23 and 80, and pair them together to where they're running in parallel, but logically we can treat them as one via the baseband. But it gives you the best of both worlds, where you kind of get the range characteristics of the lower band, but typically the higher capacity of the lower band. So we'll mention that as well. And then the series of flat panel antennas that are really only now being kind of considered by the FCC for utilization. They allow you to have some very small footprint systems that you can put on lamp poles without drawing too much of attention. We have a similar 0.1 meter antenna for E-band, for instance, that makes the solution very compact. And just some general differentiators. We're very proud of our RF performance. Our radios are kind of our bread and butter. Even across all domains, Ericsson and radio are very synonymous. But in the mini-link or the point-to-point microwave area, mini-link radios, have superior system gain, and that is basically the combination of output power and receive sensitivity, where the difference in those numbers ultimately gives you a better link budget, which can be used to drive either higher capacities or longer hops or smaller antennas potentially. So we're very proud of our RF performance, which kind of the system gain ultimately yields higher capacity. At the same time, we've done a lot with power consumption. And as I mentioned, we've been in some pretty extreme climates with mini-link. So some of those climates actually require diesel fueling or solar fuel, different sorts of ways to power a site because they're very, very remote. And we've won deals on the basis of energy performance completely. So we have things like features where we can turn down output power based on the capacity that's needed at that moment. And then the combination of features we have kind of in this suite of the portfolio is it will allow you to yield 30% less power consumption than kind of the typical average. Network evolution, as I mentioned, we have prior products. You can kind of see some of the older products shown in this picture here, but because we've been around for so long, we never leave an older generation kind of stranded. We always provide a migration path, and that is, with the baseband and the radio level. So our customers can feel secure in picking one generation and knowing that they'll always have an opportunity to grow from there. And of course, Ericsson as a single point of contact. We are a full service, full suite, offering, and now complemented with our channel partners like DoubleRadius and Wencom. We have even more coverage to be able to support our customers. I think at this point we're going to take a quick pause and introduce the other poll question. Okay, and quickly I want to talk about our router portfolio, and that is the Router 6000. So the Router 6000 is, Ericsson doesn't claim to be a full service IP company, but we do, we have put our focus on building routers that support the access network, that support our radio deployments. So we've done a lot of work with our radios and with our mini links, and to put features in that work well together. And we've seen a lot of success with the Router 6000 portfolio in the fixed wireless access markets, as well as kind of new 5G deployments, because these routers are very cost optimized, number one. So they've got a nice price point, but they also have a very nice, for instance, 10 gig port density. So as you can see, we have, across the lineup, we have a nice number of 10 gig ports, which most of them also couple as 1 gig ports if that's all you need. But it's controlled with expansion licenses. But we've seen, like for instance, very small sites where we're deploying our fixed wireless access radios. The 6471 does a good job of providing that cell site router function. And then as you go up in complexity at your sites, the 6672 and then ultimately the 6675 kind of provide the range of cell site router products that we would kind of use in this space. And I talk about a cell site router, and so that may be a term that might be unfamiliar to some of you. But I often get the question, well, why do I need one? Our baseband actually has an IP connection. Why can't I connect directly to that? Well, there's a number of reasons why you might. It actually helps with kind of easing keeping the connectivity at your site very simplistic. So if you run all, when you deploy radio at a site, you may have more than one radio baseband. For instance. So if you do that, rather than kind of daisy chaining them together and then sending it out to the transport network, running them properly through an aggregation point is kind of the first point of where backhaul would begin. It provides a nice demarcation in case you need to be able to isolate issues between your backhaul network and your core network. You can introduce test points at the cell site router that you couldn't if you maybe just use the baseband. You can implement kind of more advanced IP functionality that allows you to implement some network resiliency, things like OSPF and PFD, and some of those kind of technologies would be implemented in a cell site router that you may not always see in a baseband. Things like buffering and quality of service are some more advanced kind of packet technologies that we've observed radio really kind of requires. Radio networks, when you look at them from an end-to-end standpoint, they pass a lot of TCP traffic, and when TCP traffic doesn't get acknowledged, then it creates a lot of retransmissions. And if your buffers are too small, then ultimately the result is that you can create a retransmission storm, and congestion in the network just goes way up. So you want to have bigger buffers when you're passing this sort of traffic. And then some of the kind of even more important functions of the cell site router are security, implementing IPsec to handle untrusted backhaul, and then sync distribution. You can't always depend on GPS synchronization at cell sites anymore. There are figures that show that a GPS outage, for instance, can have a huge impact on the availability of your network. So the cell site router, like the Router 6000, has timing holdover capabilities that allow it to sustain a GPS outage for much longer. And then if you had a secondary source of timing like network sync via PTP, then obviously that is also supported through the cell site router. So things like this, kind of really make the case for having a cell site router, especially in such an economical box. And then I think this one, maybe one of my last two slides here, the Router 6000, just in the fixed wireless access use case in particular, we talked about the, some of the capabilities of the Router 6000 and the cell site router, dedicated buffer storage for video traffic. So as I mentioned, you don't want to have too many retransmissions interrupting your video stream. Obviously, a customer may see that. And then the sync capabilities we talked about. IPsec is a very hardware-intensive feature. You need, or processing-intensive feature that you need dedicated hardware for. And we have this built-in hardware acceleration for IPsec that allows us to flow through more IPsec sessions in order to carry that untrusted backhaul. In terms of supporting the transport latency, we have an average latency of about 4 milliseconds through the Router 6000. That is extremely better than a lot of the competition out there, because it's been built for this specifically. I'm going to talk about the no fan, no filter here on the next slide, and obviously low power and efficiencies. It's kind of a theme throughout our portfolio. So again, faster, more capacity, more buffer, more price savings. This is just one thing I want to highlight. So this is the Router 6672. This just shows kind of an ingenious design, I would say, where we've forced the airflow through fan or through cooling vents that do not touch the circuitry. We have this allows no dust effectively to get into the circuitry, and because you're not having to protect that circuitry, you don't necessarily need to have an airflow filter, and those filters in telecom equipment tend to need changing every few months, and so every time you have to roll a truck over to a site to go and change a filter, potential cost. So that these routers can effectively pay for themselves by avoiding truck rolls to maintain filters that we don't have in this design. Okay, that takes care of the transport portion of the portfolio. I'm going to hand it back to Arthi to give us a quick teaser on the radio access solutions.
Right. Thank you so much, Andre. Well, what Andre did not actually mention is some of our price advantage when it comes to our transport portfolio. So I would strongly urge you to, think of a configuration that we can offer and get your sales rep to quote it for you, and just look at the pricing that we can provide for our transport portfolio. I mean, you're getting tier 1 operator products for a very, very affordable price. So I would strongly urge you to do that. I mean, these products are in the AT&T's and Sprint's network today, and it is accessible to all of you as well. So now, without further ado, I just wanted to give you a quick teaser on what we can offer in addition to our radio, in addition to our microwave and also router portfolio, which is also our radio point to multi-point radio access portfolio. Andre, if you can go to the next slide. So this is actually a snapshot of all the radio hardware that Ericsson offers. We have over 150 variants in all different countries. But for the channel space, we have specifically picked all the radios that we can do CBRS band 48 to cater to this market. The three radios that I would like to point out is our Radio Dot, which is for indoor usage. We have the 4408, which is a micro radio, which can be used both indoor and outdoor. And then we have our Air 6488, which is primarily for outdoor. Andre, if you could go to the next slide. Now, from working with our WISP customers, both directly and via channels, we are very aware of the demand for fixed wireless access deployments, especially in rural America. Thanks to all the government funding, the CBRS spectrum availability, and now COVID. It has actually propped up the demand for high-speed internet and home broadband, for reliable and accessible high-speed broadband. Hence, to address this use case, Andre, if you could skip one more slide, we are offering 2 radio and 2 baseband options for fixed wireless access. The first one, as I mentioned a while ago, is the 4408. It's a micro radio. It's a small 9-pound radio that can go on poles, walls, indoor, outdoor, on towers, and also rooftop. This radio can do 6 times 20 megahertz LT carrier per radio at full allowed FCC power for CBRS. And just one of this radio per carrier per radio can do about 25 homes. So times that with 6, you can go all the way up to 150 homes with just one of these radios. And then the other radio that we offer is the 6488. It's a much larger radio, but it's larger in size and larger in power and capacity as well. It comes with an internal antenna of 23 dB, and it's mainly meant for outdoors, so on rooftops and towers. Now, the main benefit of this radio, it's its ability to do beamforming with concentrated power towards individual homes for high throughput and performance. This radio can do about 100 homes per carrier per radio. So with 3 carriers, you can do about 300 homes with just one of these radio. This radio is also capable of multi-user MIMO for about 16 beams per carrier per radio. And for the basebands, we are offering 2 kind of basebands. One is the 6630, which can offer 2 gigabits per second throughput downlink. It is more deployed in a climate control cabinet, and it can offer a peak simultaneous user of 7,000 at a time from this baseband. As for the 6303, it is more ruggedized, it's hardened, it is meant to be outdoors. You can put it, you can mount it up on a pole, on a wall, wherever you want it. It has 0 footprint, which means you don't have to pay for, for a radio pad. And this one can do about 1 gigabits throughput, serving about peak simultaneous users of 4,000 at a time. Now, Andre, if you could go to the next slide. Now, quickly to wrap it up, a snapshot of the benefits that our radio system offer is number 1, all of our radios are 5G upgradable via software, which means you don't have to swap out any hardware. All of our products, all of our radio products, all you need to do is work with the software and you are 5G ready. And that becomes really handy when CBRS goes 5G next year. The next point is our products are all based on 3GPP technology, which means this technology is here to stay, and we have a 10-year roadmap on our products already set. Then the third one is because it's 3GPP and not proprietary technology, there's a wider ecosystem of players to work with without any vendor lock-in, because I do know our products work with any kind of core, any kind of CPE, so you have the option to mix and match whichever products that you want to, and that actually in the larger scheme of things brings down the cost of all of these products, so you benefit overall. And with our FWA products or with our radio products, even though you buy it today for an FWA use case, if you're sticking to the same frequency via software, you can upgrade it to do mobile broadband, IoT, and or roaming. So again, it's all via software. Our radio products can also do carrier aggregation within the radio, between the radio, and between basebands. And last but not least, our frequency reuse. We can do frequency reuse of 1, which helps a lot in terms of spectral efficiencies. Now, I would consider this as a snapshot and a highlight to what to our radio portfolio, and we will do a follow-up on this, getting more in depth to what we can offer in terms of radio technology when it comes to fixed wireless access. And for more information, I would urge you to talk to your DoubleRadius sales representative. And with that, I will conclude our presentation and hand it back to Jocelyn. Thank you so much for this opportunity. We look forward to working with all of you.
We'd like to thank Ericsson for explaining today on how to use their mini-link for 5G transport, and we're excited to see your success in deploying with Ericsson in your network. Thanks again for joining us today. Stay safe, and we'll see you guys next time.
Thank you, Jocelyn.